Pluto, one of the dwarf planets in our solar system, discovered by the American astronomer Clyde Tombaugh in 1930, and being known for its extreme cold, may actually have an underground ocean. In this video, we're going to talk about this underground ocean on Pluto, and how is it even possible? Pluto is a dwarf planet, and as a result of it being 40 times further away from the Sun, it takes approximately 248 Earth years to complete one round. It is also a relatively small planet, being even smaller than the Moon and only half the size of the United States. Despite its size, it has been discovered that it may have seas and other subsurface water sources. The subsurface ocean was barely beginning to emerge when early times of Earth was still a molten mass with a surface swimming in liquid magma. Since then, liquid plutonium water has persisted in a far-off solar system, offering a viable home for life. Oceans are found everywhere. They are mostly found outside of our solar system. S. Alan Stern, an astronomer at the Southwest Research Institute and the mission's commander for NASA, claims that they may be homes for life. This represents a major shift in how we perceive the solar system. Scientists speculated that there may have been an ocean buried kilometers beneath Pluto's thick shell of ice when the New Horizons spacecraft performed its flyby of Pluto in 2015. This was because the surface geology of Pluto was so active and complicated. In recent years, those suspicions have become closer to being presumptions. And right now, the majority of planetary scientists concur that Pluto still possesses a worldwide ocean of liquid water beneath its surface. But how can an ocean exist on a planet that is smaller than the Moon? And how, over the period of billions of years, did it manage to prevent from freezing? Scientists believe they may have an answer to these queries as a result of a recent investigation. Astronomers previously believed that Pluto formed from cold materials slowly latching together. The dwarf planet would have gradually formed out of shards of rock and ice as a dusty disk of debris collected around our Sun. Pluto's internal heat would have melted some of its ice once it was big enough, forming a subterranean ocean. Astronomers claim that the explanation for Pluto's subsurface ocean, which involves radioactive element decay, is a plausible one. The group that conducted this most recent study, nevertheless, sought to test that hypothesis. They were interested in learning whether Pluto actually began hot inside and developed through a succession of enormous impacts similar to how early Earth did. We understand this image very well from the early inner solar system through meteorites and other things. We actually don't have a good image of the outer solar system. It turns out that by simply looking at the dwarf planet's surface, it's possible to determine whether Pluto originated hot or cold. It has to do with the obvious truth that when water freezes, it expands, and when it melts, it contracts. According to Stern, if you put a glass of water in the freezer, it will break the next day because of water expanding as it freezes. On Pluto, the same is true. Ice becomes less dense as a result of the water molecules' reduced vibration and formation of crystalline structure after freezing. This solid water also expands, which is why ice cubes float in your drink. Therefore, if Pluto began hot and subsequently gradually cooled, the surface ought to have expanded, leaving traces of geological features that resulted from the process. But if Pluto had a chilly beginning, the dwarf planet's surface ought to exhibit signs of compression dating back to early days of the universe. The researchers closely examined the data from New Horizons, looking for any indications of either compression or expansion to determine which of these two scenarios best matches the facts. A rather surprising discovery was found and left the team quite shocked. Pluto has terrains that appear to be very old, roughly the same age as the solar system, and there is no sign of compression and thus hinting it had a fast start. Black holes are one such example. In an icy world, impacts often shape clean circles, but even those are located in the earliest terrains. Pluto's craters have been elongated over time, and none of them have been compressed. After that, scientists calculated Pluto's early development using a hot start scenario. They found that Pluto was developed as a result of a rapid succession of large collisions, and heat from such explosions would continue to build up. The Kuiper Belt is an area of frozen objects and dwarf planets beyond Neptune, and this theory really fits very well with the other recent models of the early evolution of the region. Similar Kuiper Belt objects may have originated in as little as a few hundred or thousand years. It's kind of good that geology is letting us know this. People who are attempting to comprehend the dynamic of the Kuiper Belt are also coming to this conclusion. Pluto's conclusion after a strong start is a weird surprise answer. Major repercussions stem from Pluto's alleged hot start for the small world's neighbors including Eris, Makemake, and Huame. Pluto's rapid and heated formation suggests that additional dwarf planets did the same as well. Astronomers are dispelling the myth that Earth is the only ocean world in our solar system as they learn more about the frozen ocean moons around the gas giant planets. It's more likely that the liquid water content of the outer solar system is remarkably abundant. Scientists claim that there are oceans on dozens of planets, on both the inner and outer solar systems. It's one of the most important planetary science discoveries of the space age. It might not seem like a likely spot for life to develop on these alien worlds. The typical distance between Pluto and the Sun is around 4 billion miles, which is 40 times further than Earth. As a result, Pluto receives very little light from the Sun, allowing temperatures to plunge to about -400 degrees Fahrenheit on its surface. The most recent discovery adds to the mounting body of evidence indicating Pluto has long been home to an active ocean, and only just this year did another piece of the puzzle come together. The most famous feature in the universe is the frozen heart of Pluto. What appears to be a massive impact basin the size of Texas has shaped the area. Sputnik Planitia, the largest glacier in the solar system, spans 600 miles or 1,000 kilometers in the left lobe of the heart. Astronomers assume that this feature originated when another huge object struck Pluto in the past, when New Horizons first brought it into focus. The indirect nature of the evidence supporting Pluto's ocean is a problem. Although circumstantial evidence can occasionally lead to a conviction in a court of law, there is numerous circumstantial evidence. And for this reason, Stern and a group of scientists are advocating for a Pluto orbiter that would not only visit the dwarf planet again, but also orbit it. During its close approach, New Horizons only managed to get a fleeting glimpse of Pluto. Even yet, the probe only managed to take high-quality pictures of 40% of the faraway planet. Additionally, 40% of the surface was too dark for the New Horizon to even attempt to see anything. On the other side, a Pluto orbiter may be equipped with radar and laser devices that do not require visible light to view the surface. What do you think about the possibility of an ocean on Pluto? If you are interested in knowing about planets, take a look at our other video about Planet X that is shown here. If you have any topics that you want us to cover, let us know in the comment section below. We hope you enjoyed today's video, and if you did like it, we'd really appreciate if you liked it and subscribe to the channel so you don't miss out on any future videos. We'll see you in the next one. Take care.